today we are going to look at how we determine the resultant when we have forces that are not parallel to each other. Like in this particular instance, I have force 1 and force 2. There's an angle of 30 degrees between these two forces, so they are not parallel to each other. Now, how do we determine the resultant? So last time we saw that when we have vectors that are just parallel like this, it's very easy to determine the resultant. Okay, fairly easy. You just have to choose one direction as positive. But in this particular instance now, it's a different case. For us to find the resultant vector that is going to act on our object here, the steps that we need to follow are these ones. Step number 1, we need to resolve all the forces. Okay, we want to resolve all the forces that are acting at angles. So force number 1 here is acting at an angle of 30 degrees to the horizontal. We need to resolve it into its components. So we need to break it up. So I draw my vertical component. This is going to be called F1y. It's a component of F1, so it's going to be called F1y. And then from here, going in this direction here, up to that particular point, I'll have F1x. Right. So my F2 here does not have any component. It only has the horizontal component, no vertical component. So there's no need for me to resolve F2. But F1 can be resolved into F1y and F1x. Right. Now the next step after resolving your forces, you have to add all the x components. So you combine all the x components to get what's called Rx. So you would say Rx would be equal to force 1x plus force 2x plus F3x, things like that. So all the x components, you add them together, you get your Rx. Step number 3 is to add all the y components to get what's called Ry. So the way you get Ry is by adding all the vertical components, F1y plus F2y, depending on the number of forces that you're having. Step number 3 would be to sketch a vector diagram using the Rx, the Ry, and the resultant, which is R. So you first of all draw your Rx, then you draw your Ry, then you're going to complete a triangle by drawing a hypotenuse. That particular hypotenuse would be your resultant. It must start from the tail of the first vector to the head of the last vector. Right. And then step number 5 would be to use the Pythagoras theorem to calculate the magnitude of the resultant. And lastly, we'll use our simple trig ratios to determine the direction of the resultant. Alright, so step 1, resolve all the forces into their components. Step number 2, add all the x components together to get Rx. Step number 3, add all the y components to get Ry. Step number 4, draw a simple triangle or a sketch using Rx, Ry, and then R being the hypotenuse representing your resultant. And then use Pythagoras theorem to calculate the magnitude of the resultant, which is your hypotenuse. And then use your simple trig ratios to find the resultant, the direction of that particular resultant. So in other words, you're going to find the angle here. Okay, so the angle would be your direction. Now let's have an example here to see how this works. Right, here's an example. 3 forces, force 1, force 2, and force 3 act at a point as shown on the Cartesian plane in the diagram below. Right, so we can see that we have our force number 1 right here, and then we have force 2 here, and then we're having force 3 here. Now this is a Cartesian plane. On a Cartesian plane, we know that we have the x-axis and the y-axis, and this part here is the origin. So from the origin going to the right, we have positive x, we have negative x on this side. I have positive y from the origin going up, and then from the origin going down, I have a negative y. The next question says define the term resultant force, also resultant vector. So we know the resultant vector is that single vector with the same effect as all other vectors combined. 2.2 says write down the x component and the y component for force 2, F2. Right. So you can see that force number 2 here is acting at an angle. So force 2 has two components, the x component as well as the y component. Force 1 here only has y component and no x component. Right, so no x component for this guy here. For this one here, there is no y component. But this one has two components, the x component and the y component. So the question just says write them down, because it's very easy to read them from the graph. What I'll do is I'll first of all break down this particular vector into its components. So the x component will be starting from the origin here and going in this direction here. So maybe up to that particular point here. Right, this is my f2x. So I'll call this one f2x. Right, and if I read from this graph here, it's probably about 8. Yeah, so I can say 8. So 2.2, my f2x is equal to 8 newtons. Right, and then I can draw the y component for that particular vector. It ends up to somewhere there. So I think 10 will do. So this is my f2y. So I'll say f2y is equal to 10 newtons. So let me say negative 10 newtons here. Alright, which is equal to 10 newtons downwards. Alright. Okay, there we go. So these are the components that I'm having for my force. Right, for 2.3, it says calculate the net horizontal component for F1, F2, and F3. In other words, what we have to do here is to add all the x components. We must add all the x components, which means that I'll need the x component for F3, the x component for F2, the x component for F1, and combine them together. So 2.3, I would say Rx, you can say Fx if you want. Rx is equal to F1x plus F2x plus F3x. My F1x here, this one does not have any horizontal component, so I'll put 0 here. F2x, the x component is this one, which is 8, plus F3x, the x component is this one here, which is maybe negative 6. So if I add there, I'll get 2 newtons. So my x component is 2 newtons to the right, since my answer is positive. Right, there we go. And then the next question says calculate the net vertical component for force 1, force 2, and force 3. So in other words, I need to find the Ry. So 2.4, I'll say my Ry is equal to force 1y plus force 2y plus F3y. Then I check my forces. This force here only has the y component, so I'll take that one, which is 5, plus F2y. I've seen F2y is here, which is negative 10. It's pointing downwards. Plus F3y is acting, okay, F3 doesn't have any y component, it's just horizontal, so I'll put a 0 here. So my total for the y components is equal to negative 5 newtons, which is equal to 5 newtons downwards. There we go. Right. Now lastly, the question is saying calculate the magnitude and the direction of the resultant vector for all these three forces. We need the magnitude as well as the direction. So remember, we said the magnitude, we get it by using Pythagoras theorem, and the direction, you get it by using your trig ratios. So what we need to do now, since we have the Rx and the Ry, I need simply to sketch first of all a vector diagram. So Rx and Ry will become the sides of a right angle triangle. I'll start by drawing the Rx. Right, so 2.5, I'll sketch my Rx. So my Rx is pointing to the right, 2 newtons to the right. So here's my Rx. And then starting at the head here, I will draw the Ry. So my Ry is actually pointing downwards. So I'll start here and draw a 5 Newton force pointing downwards. So this is my Rx, which is equal to 2 newtons. This is my Ry, which is equal to 5 newtons. Alright. And then I must complete my triangle now by drawing a hypotenuse here. But I need to start at the tail of the first to the head of the last. So from this particular point here, I'll draw my resultant. My resultant must end there. This is my resultant. And then this angle here would be my direction. Alright. Okay, cool. Now, how do we find the resultant here? We'll say the magnitude of resultant. I know I need to use my Pythagoras theorem. So I'll say R would be equal to the square root of my Rx squared plus Ry squared. That's your Pythagoras theorem. The square root of my Rx is 2, so I'll say 2 squared plus Ry is 5, so I'll say 5 squared. This will be equal to what, 29. Alright. So I'll say the square root of 29. That will be 5.39. So this is the magnitude of the resultant. So we know that resultant is a vector. We need to find the direction of that particular resultant. So what we need to do now is to use our trig ratios to find the resultant here, the direction of the resultant. So I'll then say for the direction, of the resultant, I'll use tan theta. My opposite side is the Ry here. So Ry is opposite to the angle, Rx is adjacent to the angle. So I have 5 over 2, so this tan theta. Therefore, my theta would be equal to the arctan, or the tan inverse of 5 over 2, which will be equal to, so I'll say the tan inverse of 5 over 2. That will give me 69.2 if I round off to 2 decimal places. Alright. This is the direction, this is the magnitude. So I then conclude and say, therefore, the resultant is equal to 5.39 newtons at 69.2 degrees from the horizontal. So our angle is actually from the horizontal. This one here is from the horizontal. This is the horizontal, and from the horizontal to the resultant, the angle here is 69.2. So this is the conclusion at the end of the day. Right. But someone can decide to first of all draw the ROI component here. If you first of all draw the ROI component, then the RX component, we're going to have a different angle here. So let's just try to see how that will work out. Alright, so you can first of all draw your triangle like this. So let's see, I can say, alright, I'll first of all draw the ROI. So my ROI is actually pointing downwards. So here's my ROI, 5 newtons downwards. And then from this head, I'll draw the other vector which is pointing to the right. So here's my ROI, here's my RX. RX is 2 newtons, ROI is 5 newtons. Right, and then I would then draw the resultant starting with from the tail of the ROI to the head of the RX. So up to that particular point there, I have my resultant. And then this would be the angle of my resultant from the vertical to that particular point. Okay. Now, if you draw a triangle like this, your resultant will be the same here. You still use Pythagoras theorem, so you get the same resultant, right? The same resultant. However, for the direction, it will be a little bit different. For your direction, you would say tan theta is equal to opposite. Now, the opposite side to this angle here is my Rx. So I'll say Rx over Ry, which will be the adjacent to the angle. So tan theta would be equal to 2 over 5. Therefore, my theta would be equal to tan inverse of 2 over 5, which is equal to, so let's check. Let me just change there. Let me put a 5 there, and let me put a 2 there. So that's 21.8 degrees. So your conclusion here would be, you would say, therefore the resultant is equal to 5.39 newtons at 21.8 degrees from the vertical. Right. So this angle is being measured from the vertical, 21.8 degrees from this vertical line to my resultant. And then in this particular case, this angle here is being measured from the horizontal. So this is another way to solve your problem here. So both answers will be correct as long as you are telling us the particular angle with respect to the right vector. So this 69.2 degrees is with respect to the horizontal. This one is with respect to the vertical. And something interesting here, if you actually add this particular angle and this particular angle here, you get 90 degrees. Right? So if I decide to put this vector here, these two angles here, this particular angle and that angle, they add up to 90 degrees. Right, for this example, we are told that two forces of magnitude 50 newtons and 80 newtons act at a point on a Cartesian plane as shown in the diagram below. Right, so From this diagram, I have a 50 Newton force here, which is acting at 30 degrees to the horizontal, and I'm also having a 30 Newton force. Right, so this time they're giving us the magnitude of the forces. All right, first question. Give the correct term for the following description: a single vector with the same effect as two or more vectors together. Obviously that's a resultant. Right, 2.2.1, calculate the magnitude of the vertical component of the 50 Newton force. All right, so 2.2.1, the vertical component is my Fy, F sine theta, which is equal to 50 sine 30 degrees, which is equal to, let's see, 50 sine 30, we get 25. So that's 25 newtons. So, all right, if I break up this particular vector here, I'll have my y component up to that particular point. Fy is pointing upwards. My fx, we're pointing to the left. Right, so this 25 newtons upwards. Okay, direction is very important when it comes to vectors. 2.2.2 says calculate the magnitude of the resultant of the net resultant for everything, right? So now we need to remember here that the steps that I gave you earlier on, for me to find the resultant, I first of all have to find my Ry by adding all the y components. Then I must find the Rx by adding all the x components. Then I simply sketch my smaller unit triangle, and then I find the r, which is the hypotenuse. All right, so I'm going to do that. I'll say my Rx would be equal to f1x plus f2x, which is equal to f1x. I'll take this one as f1, which is 80, plus my f2x, the x component, this one here, I'll have to calculate it, right? So I must say minus f cos theta, which is equal to 80 plus negative 50 cos 30, which is equal to what? So let me say 80 plus negative 50 cos 30. All right, I get 36.7. So that's 36.7 newtons. That's just my Rx. So it's obviously to the right since it's positive. Okay, next up I need to find my Ry. So for the Ry, would add f1y plus f2y, which is equal to my f1y, right? This particular force here does not have any y component, so it's 0. My f2y is this particular component here, which is this one that I calculated, so that's 25 newtons. So it means that my Ry is actually equal to 25 newtons, and this is upwards as well. Right, so I now have my Rx as well as my Ry. Next up, I just need to sketch my vector diagram. So I'll take the Rx first, My Rx is pointing to the right, so I'll simply sketch a vector to the right. So this is my Rx. Alright, let me take this one down so that I can create some space there. Alright, just take it down here. Okay, fine. So this is my Rx, and then from there I need to draw my RY. Starting here, it's going upwards, so I'll draw an upward vector like that. So this is my Rx, my RY. My Rx is 36.7 newtons. My RY is 25 newtons. And then the hypotenuse here will be my resultant. So I'll have from here up to there. There is my resultant, which is R. And then this is the direction. Alright. So I'll say what? For the magnitude of my resultant, I'll use Pythagoras theorem. R is equal to the square root of Rx squared plus Ry squared, which is equal to, right, the square root of 36.7 squared plus 25 squared. So take out your calculators and calculate. So I have square root of 36.7 squared plus 25 squared. I get 44.41. So that's 44.41 newtons. This is the magnitude of the resultant. So this is what the question is asking for, the magnitude, only the magnitude of the resultant. So there we go here. Right. Next up, the question is asking for the direction of the resultant, meaning that they want this angle here. So remember, this angle will depend on how you draw your triangle. Right, so for that's 2.2.3. So for 2.2.3, I would say tan theta is equal to the opposite of hypotenuse. This side is opposite to my angle, so Ry over Rx, which is equal to 25 over 36.7. Therefore my theta is equal to the tan inverse of 25 over 36.7. Alright. Okay, so I say shift tan 25 over 36.7, close the bracket, with 34.78. So that's 34.78 degrees. Right. So we can then say, therefore, our resultant is equal to, that's 44.41 newtons at 34.78 degrees from the horizontal. My angle is being measured from the horizontal here, right? So that's how I conclude and say it's from the horizontal. But if you draw a triangle in another way, then you arrive at a different conclusion.